Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered how the justice system figures out if someone is guilty or innocent based on evidence? It is a massive challenge, and new research is trying to build a smarter way to do just that. Today we're diving deep into a fascinating paper that tackles a huge problem in criminal justice: how to measure criminal evidence in a way that can actually help us understand guilt rates and classify suspects more accurately. Think of it like trying to build a super precise scale for evidence, but instead of weighing apples, we're weighing things like eyewitness accounts and forensic matches. The main question these researchers had was this: can we create measurable scores for different types of criminal evidence so we can use fancy statistics called taxometrics to better understand how often people are truly guilty and how to tell who is guilty and who isn't? They explained that taxometrics is a way to figure out if something is made up of distinct categories or if it is more of a sliding scale. For example, are people either definitely guilty or definitely innocent, or is there a whole spectrum in between? The researchers believe that by turning different types of evidence into numbers, we can use taxometrics to get a clearer picture of guilty-suspect base rates, basically how often people are actually guilty at different stages of the justice system. This could also help us develop better ways to classify individual suspects. Now, the tricky part is, how do you turn fuzzy things like eyewitness statements or forensic reports into numbers? The paper sets out some important rules for these indexes or scores. First, they need to capture the whole range from evidence that strongly points to innocence to evidence that strongly points to guilt. Second, each index should measure something unique about a type of evidence, without too much overlap with other indexes. Think of it like having different tools in a toolbox, each designed for a specific job. Third, they need to be as precise as possible, ideally close to a continuous scale, to get the best results from the taxometric analysis. So, they developed four main types of indexes. They tackled eyewitness identifications, interviews and confessions, forensic match evidence, and something called propensity evidence, which is basically evidence about past behavior. Let's start with eyewitnesses. Imagine someone saw a crime. They might be asked to pick someone out of a lineup. The researchers proposed an index called EVW. This index considers not just whether the witness identified the suspect, but also how confident they were. If a witness is super sure they saw the suspect, that is strong evidence of guilt. If they aren't sure or they pick someone else, that points towards innocence. They even consider what happens when there are multiple witnesses. If they all agree, it is stronger evidence. Their formula for EVW basically subtracts the innocence points from the guilt points, with confidence weighting those points. A score of +1 means strong evidence of guilt, -1 means strong evidence of innocence, and 0 means it is unclear. This is pretty neat because it tries to capture a lot of nuance in just one number. They also mention a variation, EVW prime, which is a slightly different way to calculate it. Next up is evidence from interviews and interrogations. This is where suspects talk to investigators. The researchers realized that it is not just about whether someone confesses, but also about what they say. Are their stories consistent? Do their statements match other evidence in the case? They created an index called EVENT. It counts the assertions suspects make, basically factual claims. These assertions are then categorized as admissions or denials. The crucial part is whether these admissions and denials are reconcilable with the case facts, and if they're contaminated by information the investigator might have shared. Reconcilable denials and uncontaminated admissions are incriminating. Reconcilable denials and irreconcilable admissions are exculpating. Their formula looks at the difference between incriminating and exculpating assertions, divided by the total number of assertions. Again, +1 is strong evidence of guilt, -1 is strong evidence of innocence. They even suggest a slightly different version, even prime, to handle unverifiable statements differently, showing how they think about refining these measures. Forensic evidence like fingerprints or DNA is another big one. The index here is EVFM. This is complex because the reliability and methods vary wildly between different forensic disciplines. The researchers decided to create one overall index by combining evidence from various forensic techniques. They break down the forensic samples based on whether they are primarily used to confirm guilt, PPV, confirm innocence, NPV, or do both, 2PV. They then calculate an evidence score for each technique, EVT, and combine these into the final EVFM. The idea is that a match on a PPV sample is incriminating and an exclusion on an NPV sample is exculpating. They acknowledge that simply averaging things might not be perfect. And the validity of different techniques can vary, but the goal is to get a single number representing the strength of forensic evidence, ranging from -1 for innocence to +1 for guilt. Finally, they tackle propensity evidence, which is about a suspect's past criminal history. This is interesting because past behavior can predict future behavior. The index they propose, EV-prop, focuses on the similarity between a suspect's criminal history and the target offense. This one is a bit different. It requires some initial research to create a map of crime similarities. They use a technique called multidimensional scaling to figure out how similar different crimes are in terms of factors like harm or intentionality. Then, they calculate the distance between a suspect's history and the current crime on this map. A shorter distance means the past crimes are more similar to the current one, leading to a higher EV-prop score, indicating a stronger propensity for guilt. A score of 0 means no criminal history or completely dissimilar history. Importantly, this index typically points towards guilt, as a lack of criminal history doesn't actively prove innocence. Now, building these indexes is one thing, but actually using them is another. The paper wisely discusses the practical challenges. They highlight feasibility and scalability, making these judgments like whether a denial is reconcilable or if a forensic sample is truly guilt-relevant requires careful, reliable work, which can be time-consuming. They suggest starting by retroactively analyzing cases they know the outcome of, like those involving wrongful convictions where the real perpetrator was later found. This gives them a benchmark to test their indexes. They also point out that grouping different types of evidence into one index might hide important differences within those categories. For example, maybe one type of fingerprint analysis is super accurate, but another isn't. Combining them could mask these differences. This is where the "so what" really kicks in. Another big hurdle is nuisance covariance. This is when different pieces of evidence might be correlated, not because they both point to guilt, but because of how investigations are conducted. For instance, if a confession happens early, it might influence how forensic evidence is analyzed or how witnesses are interviewed later. These correlations can mess with the statistical analysis, but the researchers are optimistic, noting that taxometric methods can be robust to some of this, and consistency checks can help identify when things are going wrong. They lay out a potential workflow. First, screen the indexes to make sure they meet statistical criteria. Then, run the taxometric analysis itself. After that, use the results to classify cases. Finally, analyze the taxometric output to understand more about guilt-based rates and evidence. They emphasize that applying these methods to actual legal decisions should only happen after rigorous testing. The paper concludes by outlining the absolute crucial next steps. They need to empirically test these indexes. Do they actually produce large differences between guilty and innocent groups? How good is their construct validity, meaning do they really measure what they're supposed to be measuring, like latent guilt? They suggest lab simulations and, more importantly, analyzing real cases, starting with those where the outcome is known. This is where the rubber meets the road. The theory is sound, the indexes are clever, but do they actually work in the real world? The authors are very clear that these indexes are a starting point. They are like proposed blueprints. We need to build them, test them, see where they fall short, and then go back and improve them. So, what is my take on this research? On one hand, it is incredibly ambitious and necessary. The criminal justice system relies on evidence, and trying to quantify that evidence in a scientifically rigorous way is a massive step forward. The details of how they break down eyewitness confidence, statement checkability, and forensic sample direction are really impressive. They're really trying to build a solid foundation for understanding the weight of different evidence types. On the other hand, as they themselves acknowledge, these are complex indexes. Implementing them in real-world casework will require significant training and careful protocols. The judgments needed, like classifying assertions as reconcilable or verifiable, are still somewhat subjective and could be influenced by biases, even with the efforts to mitigate that. The sheer amount of data and cross-referencing needed for some indexes like EVENT and EVFM could be daunting. But here is the really important part for us. If this research pans out, it could lead to a more objective and data-driven approach to evaluating evidence. This could mean fewer wrongful convictions, fairer sentencing, and a better understanding of how effective different investigative techniques really are. It's about moving from gut feelings and intuition to more evidence-based decision-making, at least in how we assess the evidence itself. The future research they propose really testing these indexes on real cases, comparing different versions, and seeing how they perform in taxometric analysis is exactly what needs to happen. It's not about replacing human judgment, but about providing better tools and information to inform that judgment. We need more research on how these indexes perform in different jurisdictions and against different types of crimes. What do you all think about trying to put a number on criminal evidence? Does it feel more reliable or does it lose something in translation? Let me know your thoughts in the comments below. And if you found this breakdown helpful, give this video a thumbs up, subscribe to RUBIN'S Mind Lab for more science explained, and hit that notification bell so you don't miss our next dive into the fascinating world of psychology and beyond. Thanks for watching.